Hi to everyone. Myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to start new module, water and its treatment. In this session I am going to cover these topics. One is introduction to water and types of hardness of water, temporary hardness and permanent hardness of water, and units for the hardness of water. See, before going to this, I am going to give small introduction about water. What is water? Water is made up of two elements, hydrogen and oxygen. Hydrogen and oxygen reacts together form water molecules. The pure water has no color and no taste and does not give any smell. Means it not contains any odor. And water exists in three forms on the earth. On the earth, water is existed in three forms. What are those? One is solid form, and second one is liquid form, and third one is gaseous form. The water exists in three forms in the nature. What are they? Solid form and liquid form and gaseous form. What are the example for solid form? Ice, hail, snow and frost. These are the example for the solid form of water. And what are the example for liquid form of water? Lakes water and ocean water and river water. These all are comes under liquid form of water. What are the example for gaseous form? The rainwater and water vapor. These all are example for the gaseous form of water. The water is existed in three forms: solid form, liquid form and gaseous form. These are the example for the three different forms of water. Sources of water. There are three natural sources of water. What are they? One is surface water and above surface water, second one, and third one is groundwater. There are three natural sources of water. What are they? Surface water, above surface water and groundwater. Surface water. What is surface water? The water present on the surface of the earth, that is called surface water. What is surface water? The water present on the surface of the earth is called surface water. These are the example for surface water. What are they? Oceans, seawater, lakes and ponds. These all are comes on the surface of the water. Those are existed on the surface of the earth. And second one is above the surface water. In the example for above the surface of the water is rain. This is the example for the above the surface of the water. And third one is groundwater. Groundwater means the water is existed in the earth crust is called groundwater. Example, springs or wells. These all are comes under groundwater. See, types of hardness of water. Okay, we are going to discuss about types of hardness of water. Based on action with soap, the water is classified into two types. Based on action with soap, the water is classified into two types. One is soft water and second one is hard water. Types of hardness of water. In this, two types are there. One is soft water and hard water. Based on action with soap. See, soft water. The water which contains sodium and potassium salts, that called soft water. The water which contains sodium and potassium salts, that salts are called soft water. The water which contains sodium and potassium salts, then that water is called soft water. The water which can give lather with soap solution is called soft water. Other way, the water which gives lather with soap solution is called soft water. See, here soap nothing but sodium stearate. Sodium stearate we can call as soap. The soap reacts with soft water. The soap reacts with soft water. It gives sodium hydroxide and stearic acid. Soft water. Soap reacts with soft water. Otherwise, sodium stearate, nothing but soap. The soap reacts with soft water. Okay. Soft water means the water which contains sodium and potassium salts. It gives sodium hydroxide and stearic acid. This stearic acid reacts together with sodium stearate. The stearic acid reacts with sodium stearate. It gives the formation of lather. See, in this case, first the soft water reacts with sodium stearate or soap solution. It gives sodium hydroxide and stearic acid. This stearic acid again reacts with sodium stearate or soap. It gives formation of lather. It is called soft water. Based on soap action, the hardness of water is classified into two types. One is soft water and second one is hard water. Soft water means the water which contains sodium and potassium salt. That water is called soft water. In the soft water, when it reacts with soap, the soft water reacts with soap or stearic acid. Okay, sodium stearate. So the soap water or sodium stearate, thus reacts with soft water. It produces sodium hydroxide and stearic acid. This stearic acid again reacts with sodium stearate or soap solution. It forms lather. Then hard water. Hard water nothing but the water which contain calcium and magnesium salts. That water is called hard water. What is hard water? The water which contains calcium and magnesium salts. That water is called hard water. Calcium magnesium salts means any calcium magnesium salts. Maybe calcium bicarbonate, magnesium bicarbonate, calcium chloride, magnesium nitrate, calcium nitrate. These all are comes under magnesium and calcium salts. If these salts present, calcium, magnesium, these salts present in the water, that water is called hard water. The water which cannot give lather with soap easily is called hard water. The water which cannot give lather with soap solution is called hard water. The soft water contain calcium and the soft water contains sodium and potassium ions. The hard water contains calcium and magnesium salts. The soft water gives lather with soap solution. Here the magnesium and calcium salt will not give lather with soap solution. That is called soft water, and the calcium magnesium salts present in the water is called hard water. See, in the case of hard water, it will not give lather with soap solution. See the chemical reactions. Sodium stearate. Sodium stearate nothing but soap solution. It reacts with calcium plus 2 ions present in the water. It forms calcium stearate. That is the insoluble salt that will not soluble in water. So this sodium stearate means soap, and again it reacts with magnesium salts present in the water. It forms magnesium stearate. These calcium stearate and magnesium stearates are insoluble in water. So this calcium and magnesium stearate ions will not form lather with soap solution. It will form scum with the water. The minerals and hard water reacts with soap and forms scum. So more soap is needed to form lather. Hence they are not suitable for washing. In case of soft water, the water which contains sodium and potassium ions, the sodium and potassium ions called soft water. This soft water reacts with sodium stearate or soap solution. It forms lather. Okay. But hard water. In hard water means the water which contains calcium and magnesium salts. It will not produce lather with soap solution or sodium stearate. When these reacts with sodium stearate, hard water reacts with sodium stearate or soap solution, it produces insoluble salts like calcium stearate and magnesium stearate. So in the case of hard water, if you use hard water, more soap is required to wash the clothes. So it is not suitable. Hard water is not suitable for washing purpose. See, differences between hard and soft waters. This is hard water and soft water. See, soap is not so effective in case of hard water. In case of hard water, soap is so not effective. Means in hard water, calcium and magnesium salts are there. So it will not produce lather with soap solution. So we require more soap in the case if you use for washing purpose. Soft water. In case of soft water, soap is easily effective. Means less amount of soap is required to wash the clothes in case of use soft water. No foam and lather from soaps. No foam and lather from soaps. And if you use hard water, the soap will not form any lather. If you use soft water, the soap solution form lather. Leaves spots on the washed dishes after they are dried. If you use hard water, the hard water leaves the spots on the washed dishes after they are dried. But if you use soft water, it does not leave any spots on the dishes after they are dried. In case of hard water, it contains minerals like magnesium and calcium. Hard water contains calcium and magnesium minerals. In case of soft water, it contains sodium and potassium ions. Examples for hard water is groundwater like deep wells. Example for hard water is groundwater like deep wells. The soft water examples are rainwater. These are examples for soft water and hard water. Totally, these are the differences between hard water and soft waters. See, disadvantage of hard water. See, what are the disadvantages with hard water? In textile industry, if we use hard water, what happens? In textile industry, if you use hard water, the calcium and magnesium salts present in the hard water reacts with dye. It will form precipitate. So it will affect the clothes or colors of the clothes. So calcium and magnesium plus 2 ions of hard water reacts with dye molecule and precipitate the dye. The precipitate of calcium and magnesium soaps adhere the fabrics and cause problems. These precipitates of calcium and magnesium soaps adhere to the fabrics. It adhere to the fabrics and cause the problem to the clothes. Okay. This is the disadvantages in textile industry. If you use hard water in textile industry, the dye reacts with calcium and magnesium salts that forms precipitates. See the disadvantage of hard water in sugar industry. In sugar industry, if you use hard water, the easy crystallization of cane sugar is not found. So that is the disadvantage in case of sugar industry. If you use soft water, the crystallization takes place very easy. Sugar cane juice crystallization takes place very easy if you use soft water. If you use hard water, the crystallization is not easy in the case of sugar industry. Dyeing industry. The dissolved salts in hard water may react with costly dyes forming precipitate. In dyeing industry also, the calcium magnesium salts present in the hard water reacts with dyes, it forms precipitates. Paper industry. Calcium and magnesium salts, iron salts, these are the hardness causing salts. These reacts with water may affect the quality of the paper. The salts present in water like calcium and magnesium iron salts, these affect the quality of the paper. See, this is the, if you use soft water in case of paper industry, this is the color, the very white color. If you use hard water instead of soft water, this is the color of the paper, means the quality of the paper will be decreased if you use hard water. The disadvantages of hard water in pharmaceutical industry. What is the disadvantage of hard water in the pharmaceutical industry? See, hard water may cause some undesirable products while preparation of pharmaceutical products. If you use hard water in case of soft water in pharmaceutical industry, it will produce undesirable product, means not useful products. They may cause the harmful to the health. So, pharmaceutical industry, the hard water may produce undesirable products. Okay, that purpose we can't use the hard water in the pharmaceutical industry. Concrete making. If you use hard water in case of concrete making, the strength of the concrete will be decreased. Okay, if you use hard water in case of concrete making, the strength of the concrete will be decreased. That is the disadvantage of hard water. In laundry, already we discussed if you use hard water, more amount of soap solution is required. So that is the disadvantage of the laundry industry. Okay, the hard water, if you use it in laundry, causes much of the soap used in the washing to go as waste iron salts, may even causes coloration of the clothes. Okay, this is the disadvantage of the hard water. See, types of hardness. The hardness of water is two types. One is temporary hardness and second one is permanent hardness. The hardness of water is two types. One is temporary hardness and second one is permanent hardness. What is hardness of water? The water which contains calcium and magnesium salts, that is called hard water. Again, the hard water is two types. One is temporary hardness of water and second one is permanent hardness of water. See, temporary hardness of water. It is due to the temporary hardness of water means the water which contains calcium and magnesium salts, in that calcium and magnesium bicarbonates. The water which contains calcium and magnesium bicarbonate, that water is called temporary hardness. What is temporary hardness? The water which contains calcium and magnesium bicarbonates, that water is called temporary hardness of water. The hardness that can be removed simply by boiling. The temporary hardness can be simply removed by using boiling technique. Okay na? By boiling we can remove the temporary hardness. See, if water contain calcium bicarbonate and magnesium bicarbonate, okay, this is called temporary hardness. If you heat this temporary hardness of water, we can remove this temporary hardness. If you heat the calcium bicarbonate, it will produce calcium carbonate and water and carbon dioxide. When we heat the calcium bicarbonate and magnesium bicarbonate containing temporary hardness of water, if you heat this temporary hard water, what will the products? If you heat the calcium bicarbonate, it will produce calcium carbonate, water, and it releases carbon dioxide. In the same way, if you heat magnesium bicarbonate, it will produce magnesium hydroxide and carbon dioxide. See, These calcium bicarbonate, magnesium bicarbonates are soluble in water. Okay, that is called temporary hard water. If you heat the temporary hard water, what happens? The soluble calcium and magnesium bicarbonates converted into calcium carbonate and magnesium hydroxide. These are the precipitates in water. If you heat the soluble bicarbonates of calcium and magnesium, it will produce calcium carbonate and magnesium hydroxide. These are the insoluble products in water. So, by simple filtration, we can remove these calcium carbonate and magnesium hydroxide precipitate from the water. So, in this way, we can remove the temporary hardness. Temporary hardness can be removed by simply boiling. Okay. Once again, I will discuss. What is temporary hardness of water? The temporary hardness of water nothing but the water which contains calcium and magnesium bicarbonates, that is called temporary hardness of water. The temporary hardness of water simply can remove by boiling. Okay, by simply heating we can remove the temporary hardness of water. See, temporary hardness of water contain calcium and magnesium bicarbonates. If you heat this calcium bicarbonate and magnesium bicarbonate, on heating the calcium bicarbonate converted to calcium carbonate and it releases carbon dioxide. If you heat magnesium carbonate, it will produce magnesium hydroxide and carbon dioxide. These calcium carbonate and magnesium hydroxides are precipitate. So, by simple filtration, we can remove these precipitate. So, we will get the soft water. By removing, we can easily remove the temporary hardness of water by simple boiling. See, next, permanent hardness. What is permanent hardness? The permanent hardness is nothing but the water which contains calcium magnesium salts other than calcium bicarbonate and magnesium bicarbonate. Okay, other than calcium bicarbonate and magnesium bicarbonate, the water which contains other than calcium magnesium and magnesium bicarbonates, other salts present, that is called permanent hardness of water. Permanent hardness of water contains calcium chloride, calcium sulfate, magnesium chloride and magnesium sulfate and nitrates. These are the salts present in permanent hardness of water. So these salts cannot be removed simply by boiling. Okay, temporary hardness we can remove by simple boiling, but permanent hardness we can't remove by simple boiling. What is temporary hardness? Temporary hardness nothing but the water which contain calcium and magnesium bicarbonates. What is permanent hardness? The permanent hardness nothing but except calcium bicarbonate and magnesium bicarbonate, other than these other calcium magnesium salts present in the water, that water is called permanent hardness of water. Okay, these are the salts present in the permanent hardness of water. Okay, what is other than these salts? Fe plus 3, aluminum, manganese plus 2. These also show the permanent hardness in the water. Okay, we can't remove the permanent hardness of water by simple boiling. See, let's take these are the salts present in the water. Okay, calcium bicarbonate, magnesium bicarbonate, calcium sulfate, magnesium sulfate. Let's take 5 grams of 5 grams of magnesium sulfate. Okay, 10 grams of magnesium sulfate and 15 grams of magnesium sulfate and 20 grams of magnesium sulfate. If you take this, first I have taken 5 grams of magnesium sulfate and 10 grams of magnesium sulfate, 15 grams of magnesium sulfate and 20 grams of magnesium sulfate. If you see these four, which shows more hardness of water. Okay, in these four, 5 grams of magnesium sulfate, 10 grams of magnesium sulfate, 15 grams of magnesium sulfate and 20 grams of magnesium sulfate. In these four salts, okay, which one shows higher hardness of the water? See, the salt is magnesium sulfate, always same. So, by based on the amount, we can tell the which one shows the highest hardness of the water. See, first case 5 grams, second case 10 grams, and third case 15 grams, and fourth case 20 grams. So, these 20 grams of magnesium sulfate shows highest hardness of the water. How we can say the salt is magnesium sulfate? So, based on amount, we can say which one show highest hardness of the water. Okay, let's take other example. In this case, I am taking 5 grams of calcium bicarbonate and same 5 grams of magnesium bicarbonate and 5 grams of calcium sulfate and 5 grams of magnesium sulfate. In these four salts, which one show highest hardness? Can we say? We can't say because the amount is same, 5 grams, 5 grams, 5 grams. But if you see these salts, in the previous case, the salt is same, but in this case, these are four different salts. calcium bicarbonate, magnesium bicarbonate, calcium sulfate and magnesium sulfate. These molecular weights are different. So we can't compare. So comparison purpose and to calculate the hardness of water. So first we have to convert these hardness causing salts into calcium carbonate equivalent. That is called degree of hardness. We have to measure the degree of hardness. Otherwise, we have to convert these hardness causing salts into the calcium carbonate equivalent. Okay. To compare purpose and to measure the hardness of the water, we have to convert these hardness causing salts into the calcium carbonate equivalent. Okay. Then why we have to convert into CaCO3 equivalent? Why should not take other salts, magnesium chloride, magnesium sulfate? Why we have to take only calcium carbonate? See, this is the purpose we have to take calcium carbonate. See, what are they? First one is the molecular weight of calcium carbonate is 100. The molecular weight of the calcium carbonate is 100. The equivalent weight of the calcium carbonate is 50. So, for the simple calculations, we choose the calcium carbonate because the molecular weight of calcium carbonate is 100 and its molecular gram molecular weight is becomes the gram equivalent weight is becomes to the 50. So, simple calculation we can do by using this calcium carbonate. And the CaCO3 is very insoluble precipitate in water. So, by CaCO3 is very insoluble precipitate in water. So, if CaCO3 present in water, we can simply remove by filtration. These two reasons, because of these two reasons, we have to convert our hardness causing salts into calcium carbonate equivalent. What are those? First one is for simple calculation. The second one is calcium carbonate is insoluble in water. These are the reason for to choose the calcium carbonate other than other salts. Units of hardness. These are the units of the hardness of water. We can measure the hardness of water into different units. The first one is parts per million or ppm. What is parts per million ppm? It is number of parts of equivalents of CaCO3 hardness causing salt present in the 1 million parts or 10 to the power of 6 of water. What is parts per million, or it is also called ppm? It is the number of parts of equivalents of CaCO3 hardness causing salt present in 1 million part of or 10 to the power of 6 of water. 1 ppm equal to 1 part of calcium carbonate equivalent present in 10 to the power of 6 part of water. This is the parts per million or ppm. The second unit is milligram per liter. The number of milligrams of calcium carbonate equivalent hardness causing salt present in 1 liter of hard water. What is milligram per liter? The number of milligrams of calcium carbonate equivalent hardness causing salt present in 1 liter of hard water. Example, 1 milligram per liter means 1 milligram of equivalent of calcium carbonate present in 1 liter of hardness of water. This is called milligram per liter. The third unit is degree clerk. The third unit is degree clerk. It is the number of parts of calcium carbonate equivalents of hardness causing salt present in 70,000 parts of water. What is degree clerk? It is the number of parts of calcium carbonate equivalents of hardness causing salt in 70,000 parts of water. 1 degree clerk equal to 1 part of calcium carbonate equivalent hardness per 70,000 parts of water. That is called degree clerk. The fourth unit is degree French. The fourth unit is degree French. It is French unit. The degree French is French unit. The number of parts of calcium carbonate equivalents of hardness causing substance in 10 to the power of 5 parts of water. What is degree French? The number of parts of calcium carbonate equivalents of hardness causing salt present in 10 to the power of 5 parts of water. This is the table. This is the important table. It is the interconversion. How we can interconvert from ppm to degree clerk or degree French or milligram per liter. This is the table. See, 1 ppm equal to 1 milligram per liter, that is equal to 0.07 degree clerk, and that is equal to 0.1 degree French. This is the interconversion table. By using this interconversion, we can convert the ppm into degree clerk or ppm into degree French or degree clerk into degree French. One unit to other unit we can convert very easily by using this table. Okay, what is the table? 1 ppm equal to 1 milligram per liter equal to 0.07 degree clerk equal to 0.1 degree French. See, we are 1 degree clerk equal to how many degree French? How we can calculate? See, we have to choose degree clerk to degree French. What is degree clerk? 0.07 degree clerk equal to 0.1 degree French. So then 1 degree clerk becomes 0.1 degree by 0.07 degree French. So 1 degree clerk becomes 1.43 degree French. In this way, we can convert one unit to another unit by using this interconversion table. See, this is the problem. See, a water sample contains 204 milligrams of calcium sulfate per liter. Calculate hardness in ppm, degree clerk, degree French in terms of calcium carbonate equivalents. What is the question? A water sample contains 204 milligrams of calcium sulfate per liter. Calculate hardness in ppm and degree clerk and degree French in terms of calcium carbonate equivalent. Before calculating to this problem, we have to convert these calcium sulfate 204 milligrams of calcium sulfate into the calcium carbonate equivalent. How we can convert? See, this is important. First we have to convert into these hardness causing salts into calcium carbonate equivalent. How we can convert? See, CaCO3 calcium carbonate equivalent equal to mass of the hardness producing salt into multiplication factor. By using this formula, we can convert this hardness causing salt into the calcium carbonate equivalent weight. Okay, the CaCO3 equal to mass of hardness producing salt into multiplication factor. What is multiplication factor? Multiplication factor nothing but 100 by molecular weight of hardness causing salt. Okay, that is the multiplication factor. What is the conversion? How we can convert the calcium carbonate equivalent? This is calcium carbonate equivalent equal to mass of hardness producing salt into multiplication factor. What is multiplication factor? Multiplication factor nothing but 100 divided by molecular weight of the hardness causing salt. See, in this question what is has given? 204 milligrams of calcium sulfate. Here hardness causing salt what is? Calcium sulfate. And how much amount he has given? 204 milligrams he has given. How we can convert into calcium carbonate equivalent? Calcium carbonate equivalent equal to mass of hardness producing salt into multiplication factor. How much he has given? Mass of the hardness producing salt. He has given hardness causing salt is calcium sulfate. How much he has given? 204 milligrams. So 204 milligrams into multiplication factor. What is multiplication factor? Multiplication factor nothing but 100 by molecular weight of hardness causing salt. Okay na? So 204 into 100 by what is molecular weight of hardness causing salt? Hardness causing salt is calcium sulfate. What is the molecular weight of hardness causing salt? Calcium sulfate. The calcium sulfate molecular weight is 136. So if you solve, it will convert into calcium carbonate equivalent. How much you will get? We will get 150 milligram per liter. Okay, you will get in milligram per liter. He has given milligram per liter. We will get answer in milligram per liter in calcium carbonate equivalent. How much you got calcium carbonate equivalent? 150 milligram per liter. In conversion, see, in conversion what he has given? 1 ppm equal to 1 milligram per liter. Nothing but 1 milligram per liter equal to 1 ppm. So what happens? 150 milligram per liter we can write as 150 ppm because 1 milligram per liter equal to 1 ppm. So in this way 150 milligram per liter we can write as 150 ppm. So what is the question? We have to tell this hardness in terms of ppm, degree clerk and degree French. We got answer in milligram per liter and ppm. Okay na? We have to convert these ppm or milligram per liter into degree clerk and degree French. This is the interconversion table. 1 ppm equal to 1 milligram per liter equal to 0.07 degree clerk equal to 0.0 degree French. So first we have to convert. We got in milligram per liter na, so we have to convert into degree French. See the relation between ppm to milligram per liter and degree clerk. First we have to convert into degree clerk. See 1 ppm equal to 0.07 degree clerk. How much you got hardness in calcium carbonate equivalent terms? 150 ppm you got. So for 1 ppm 0.07 degree clerk. For 150 ppm, so you have to multiply it 150 and right hand and left hand side. Okay, into 1 ppm. Here 0.07 degree into 150. This is degree clerk. So 150 ppm becomes 0.07 into 150, that is 10.5 degree clerk hardness. This is the units in degree clerk. Similar way, we have to convert this ppm into degree French. For that, we have to select ppm and degree French relation from the interconversion table. See, 1 ppm equal to what is given in the interconversion table, 0.1 degree French. Okay, 1 ppm equal to 0.1 degree French. How much ppm you got? 150 ppm. So this 150 ppm you have to tell in degree French. Then you have to multiply left hand side and right hand side with 150. So 150 into 1 ppm equal to 150 into 0.1 degree French. So 150 ppm equal to 0.1 into 150 degree French. How much you will get? 150 into 0.1 degree French, that is 15 degree French. So first, in this way, we have to calculate the degree clerk and degree French and hardness of water. Okay, according to question, first we have to find out hardness causing salt. Then we have to convert this hardness causing salt into calcium carbonate equivalent. In calcium carbonate equivalent, we will get in milligram per liter or milligram per liter or ppm. We will get the values of hardness. Then we have to convert this degree. Then we have to convert this ppm hardness into the degree clerk or degree French by using this interconversion table. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.